Hey everybody, welcome to another amazing day of chemistry. We are going to be looking at another important physical property of matter. We've been discussing matter, anything that has mass and occupies space, and we realize that one of the key properties that we discuss when we discuss matter is density. And so this should be a review for many of you. However, this is going to be something you can use throughout the year to remind you about density. So a couple of demonstrations of these were already done. For example, the blue food coloring that was with water, and then the yellow dyed sodium chloride and water, salt water, and we saw the differences in those two with the demonstration. We also saw the demonstration of Coke and Diet Coke, so you know that at your next pool party, you could throw a bunch of Cokes in the pool, you throw a bunch of Diet Cokes, and you realize those Diet Cokes are going to float on top of the pool for you, for your guests, and those regular Cokes, well, they're going to have to swim down and get those, and we discussed the differences there between Coke and Diet Coke. Moving past the aspartame that we discussed a little bit in the demonstration, we're going to get right to our key information for density. We know, as I said, it is a physical property. Physical properties include color, size, shape, and odor, and the physical property for density really is you're measuring how tightly the matter is packed together. The more tightly packed the matter is together, the more dense it will be. The less tightly packed, the less dense it will be. There's a simple equation we can use to solve for density, and that is density is equal to mass of a substance per unit of volume. And you guys have already realized the equation we use for density is mass divided by volume, or DMV, hey, the place where you can go get your driver's license, and many of you already have or will at some point soon. Density equals mass divided by volume. Department of Motor Vehicles, DMV. An easy way to remember it. Another easy way to remember density is that we love density. And so you can think of density as the following. Density equals a big heart. That's not the prettiest heart, but there we go. We have the M on top and the V below. Just an easy way to remember those equations. Now, many times when we're solving density problems, we have to solve for the mass or we have to solve for the volume. So we can quickly move that around algebraically to solve for those. So let's say that we want to solve for the mass of a substance. Well, to solve for mass, we just take the density times the volume. It's a simple little equation, and I'll show you an example in just a couple minutes. How about if we want to solve for the volume? Well, volume is equal to the mass divided by the density. And so there's a simple little equation we can use to solve for it also. And so we know that the units we use for density most of the time in our chemistry room are grams per milliliter. Why? Because we're measuring in grams using an electronic balance, and we're using a graduated cylinder to measure the volume of things in milliliters. For example, one of the densities you should know is water. Water has a density of 1 gram per milliliter. When you measure the density of solids, most of the time we measure it in grams per centimeters cubed, and the reason is grams is what we measure it on the electronic balance, as I mentioned, and centimeters cubed would be if we're doing length times width times height, for example, for the volume of a cube or a square, for example. So grams per centimeter cubed. Now I need you to realize, however, that 1 milliliter is equal to 1 centimeter cubed. In other words, they're exactly the same thing. So we can say that water has a density of 1 gram per milliliter, or we can say that water has a density of 1 gram per centimeter cubed. They're the same thing. So if I have 50 milliliters of a substance, we know that's equal to 50 centimeters cubed of that substance. So it's an easy 1-to-1 ratio. Just want you to get that in your head. Grams per milliliter, grams per centimeter cubed, either one of those units work well. Most of the time for liquids, we use gram per milliliters, and solids, grams per centimeter cubed. One of the things that we looked at in the video that you saw in the Edpuzzle of density was that we know that as we increase the temperature, that the density of substances decreases. And so because the density of these substances decreases, why? Because when you heat them up, the particles get further and further apart. They have more energy, they move around more freely, and because of that, they become less tightly packed. Less tightly packed means less dense. And so just about every substance, as you go from a solid to a liquid to a gas, and you heat that substance up, it becomes less dense. There was an exception, and there is an exception. That one big exception is when you take pure water, or water, and you freeze it into ice at 0 degrees Celsius, or 273 Kelvin, or 32 degrees Fahrenheit. When you get it down to those temperatures, it actually changes the structure slightly and actually becomes less dense. Very unusual. Most substances do not do that. But one of the key things I want you to realize is that if you increase the temperature, let me fix that. If you increase the temperature, what happens to the density? It decreases. The density decreases as you increase temperature. What is this relationship? Well, it's an indirect relationship, or it's an inverse relationship. You could think of it either way. They do the opposite of each other. Remember that one exception? Good old water, and here it is. So when you take a look at ice and water, we have two hydrogens and an oxygen. So these little white atoms are our hydrogen and oxygens there. These hydrogen and oxygen atoms are able to slip past each other when they're in the water form. But as they form more hydrogen bonds, they actually form a little structure here, and you see that this becomes less tightly packed. And because it becomes less tightly packed, it becomes less dense. A very unusual property. We'll learn more about that when we discuss solutions and specifically water in more detail down the road. Now, a very important part that I want you to understand about density is that density is an intensive property. In other words, it doesn't depend on the size of the sample. Examples would be density, color, or odor. Now, let's say that I have a substance like a big chunk of gold. Say I have this big chunk of gold. Big chunk of gold. And let's say that I have this big chunk of gold, and I found this big chunk of gold because I'm out there looking for ships that have sunk, and I find this big chunk of gold, and I'm coming up with this big chunk of gold, and then all of a sudden, I get sideswiped by a dolphin. I don't know why a dolphin. Dolphin sideswipes me. And what happens? I drop this big chunk of gold. I drop this big chunk of gold into the ocean, back into the ocean where I was bringing it up from. What's going to happen to it? Well, it's going to sink. Why is that? Well, obviously it has to do with density. We already saw that water has a density of 1 gram per milliliter, or 1 gram per centimeter cubed. Let's look at the density of gold. I can go to my periodic table, and I want to show you this real quickly. And this is the periodic table that we've learned, the virtual periodic table that I've shown you and I've shared with you and that I'd like you to continue to use. And so I need to find gold in my periodic table. Here's gold right in the center there, number 79. I can go to a little chart over here on the left-hand side, and I can scroll down on this chart, and I can go scroll down on this chart, and I can see that there is density. And let me bring it up for you here. I can see density pretty clearly here towards the bottom. And there's something I want you to realize. If I click on this, it changes all of the periodic table so that it shows me their densities. And also, I don't want it in grams, kilograms per meters cubed. Most of the time, we're doing it in grams per centimeters cubed, so make sure we switch that. Notice, change it to grams per centimeter cubed. And again, if I click on density, it shows me all these densities. I'm going to go over here to gold, back over here to gold so we can look at it. And let me clear that out, sorry. And we can see gold, and there it is, 19.3. Man, that is pretty dense substance. In fact, it's a very, very dense substance. And so if we go back to our information here, we see that the density of this gold happens to be 19.3 grams per centimeter cubed. So obviously we know that it's going to sink deep into the ocean. But let's say that while it started to go down, I just grabbed it slightly, and I got a little sliver of it, just a tiny little sliver, just underneath my finger, a tiny little piece of gold. I'm like, oh, good, I get to save some of this gold. But all of a sudden, a big windstorm comes, and it blows off that piece of gold out of my fingernail. What's it going to do? Well, it lands here. It's like a little feather. Guess what it's going to do? It's going to sink. It doesn't matter if I have a big chunk of gold or a little sliver of gold. The density has not changed. Let me give you another example. Let's say that I have... let's see here. Let's clear this out real quickly. Let's say that I have my eraser that I have in the front. And so let me draw an eraser here for you. It's not going to be the nicest eraser, but that's okay. I have my eraser here, and I want to measure its density. So we know to measure the density of the eraser is density is equal to mass of the eraser divided by its volume. And so I decided I want to get the density of my eraser, and I take and get the mass on my graduated cylinder. Let's say that it weighs 200 grams. And I get the volume. How do I get that? Do length times width times the height of it. And I get that, and say that it came out to be 100 centimeters cubed. Again, I just made up these numbers, but let's just pretend that we did that. The density would then be 2 grams per centimeter cubed. Let's say I decided to cut this eraser right in half. I took it right in half, and I only have half of the eraser left. Exactly in half. Okay, and I want to get its density. Well, we know if I took half of it, that means the mass would be half the amount, and the volume would be half the amount. Okay, so I have half the mass because I took exactly half, and I have half the volume because, again, I took exactly half. What happened to the density? Well, guess what? It's still 2 grams per centimeter cubed. Let's say I decide to take half of that half. In other words, I have a quarter of the amount of the eraser that I had in the first place. Well, guess what? If I take half of that half, that means I'd have 50 and 25. I'd have 50 grams and 25 centimeters cubed. Sorry for my bad writing. 50 divided by 25 gives us 2 grams per centimeter cubed. In other words, it does not matter how much I have of the substance, its density stays the same. This is an intensive property of that substance. So going back to our notes here. So we realize that, yes, it is an intensive property. It doesn't matter how much I have. Compare that to the other parts of density that we were just looking at. Let me clear this out real quick for you. And that is mass and volume themselves, those are extensive properties. Yes, the mass changed that whole time and the volume changed. So the amounts changed, those are called extensive properties compared to density being an intensive property. Let's go ahead and do a simple little practice problem here to make sure you're on the right track. I want to make sure you can do these problems. And so a block of aluminum occupies a volume of 10 milliliters and weighs 27 grams. What is its density? Well, we know to solve for density, it's equal to mass divided by volume. I can quickly plug in my information here. My mass is 27.0 grams, and my volume is 10.0 milliliters. They both have 3 significant figures, so when I solve this, this is going to be 2.070 grams per milliliter. There is my density for my aluminum. Now, how do I know that that's correct? I can check my periodic table. Let's go to my periodic table real quickly, and let me find aluminum. Hey, there's aluminum, and I've already clicked on the idea that these are densities we're looking at, and there it is, 2.7 grams per centimeter cubed, or grams per milliliter. Absolutely, and I've just solved the density of my aluminum. Now, going back to our problem here, now it's asking us to solve for the mass. And so in order to solve for the mass of a substance, we know that mass is equal to the density times the volume. So if we have a density of a substance and say that the density of that substance is what? Well, we don't know what the density of lead is. It doesn't give it to us here. So where would I find that information? Well, obviously we can go to our periodic table and we can find lead. And so we can see lead over here on our periodic table, and we see its density is 11.34. A reminder, this number down below normally tells you atomic mass, but I went over here to our information on the side here, and I went down to density and I clicked on it. Notice I can click on any of these ones I want to, and it changes the periodic table inside. But I want to make sure I'm on density, and I want to make sure I'm on grams per centimeter cubed. And then I can go over there and look at lead, and I see, yes, it's 11.34. So I can go ahead and plug in my information here. I see that the density of lead is 11.34 grams per milliliter. And I also see that the volume, hey, I multiply that by the volume, which is 4.7 milliliters. I multiply those together, and notice milliliters are going to cancel, and what am I going to be left with? I'm going to be left with grams. My answer comes out to be 53.345 grams. However, I'm not going to use that answer. I'm going to cross it out. Why? Because notice, 2 significant figures. Our answer has 2 significant figures. We're never going to use the densities from our periodic table to determine sig figs, and because that is not a measurement we did, those are just considered infinite numbers. So the densities, we're not going to use those. So if I need to round it to 2 sig figs, that comes out to 53 grams. We're done. All right, one more practice problem. Find the volume of a 200 grams of gold. Okay, I can find volume. Using my notes up above, I realize volume is equal to the mass divided by the density. I plug in my mass, which is 200 grams. 200 grams. Notice 4 significant figures that it has. And then the density. Well, where do I get the density of gold? Again, I go to my periodic table. I look for gold. And let's find it real quickly here. And I see gold right in the middle there, 19.3. Oh, we already looked at that answer too. We solved it earlier, 19.3 grams per milliliter or centimeter cubed. Remember, it could go either way. Notice grams are going to cancel, and I'm going to get my answer. And my answer comes out to be 10.36 grams. Sorry, nope, that's wrong. Volume, centimeters cubed. Oh, we're doing it in milliliters, so let's change it to milliliters. Guess what? It doesn't really matter, though. You could use either one. 10.36 milliliters of the volume, or 10.36 centimeters cubed. Remember, milliliters and centimeters cubed are in a 1-to-1 ratio. All right, last little part here. Let's say that I have 4 insoluble liquids. What does it mean by insoluble? It means that they do not dissolve together. They're insoluble. So if I have these 4 liquids that do not mix together evenly, don't dissolve together, we know we'll have a heterogeneous mixture. Let's say I placed these into my beaker. I placed them one at a time into my beaker here. We know they're not going to dissolve together. So one of these would go to the very bottom, and one would be at the very top. Which order would they layer out in? Which order would these layer out in? Okay, thank you for answering those questions. Quick review of density. Density equals mass divided by volume. We can solve for the mass or the volume. As long as we have 2 of the variables, we can get the other unknown. Great job with density. You need to complete the density practice worksheet. Use these notes for your reference. Everybody have an awesome day.